Hi, this is Jaran. My lab ID is number 9. Today I'm going to explain my part in the Lab 2. I have contributed to task 1 and task of the questions, the first question and the second question right here from the Lab 2. Uh, so basically here I'm going to work on the um, sklearn and matplotlib packages, and I've implemented functions on bias, SVM, and Kane. Mm, So for the sake of simplicity, I've used the iris dataset here for the navy bias. Navy bias uses the Gaussian NB function. There are multiple methods of navy bias. So for the sake of simplicity, I've used Gaussian NB function, and I've used the testing. I've taken the training and testing validations here. So as Kane uses, they have and then also graph the dataset using the matplotlib function. These are different three classes formed after the naive bias. Have taken the nearest neighbors to be 11. For this, the accuracy is found to be 0.95, and for the classification, it shows 0.93%. For the SVM, I've used a similar dataset. I have trained the dataset into two parts. The test size to be 0.2, and I have taken multiple functions called the SVC function out there, and I have tried to fit the model into the various formats to form the accuracy score in a similar way. I have understood how to use the data and perform support vector machines here, and I have performed various graphical images to really depict the support vector machines performance on the Alice dataset. Here is the output, working output. There are multiple graphs taken for the multiple data sets, and each epochs. Yeah, here you go. For different gamma levels, I have taken the different support vector machine plottings. This is nearest neighbor. Nearest neighbor uses the same function where uh, the method we use is a nearest classifier. The number of neighbors depends on. I have taken the number of neighbors to like in the range of 50 for each range. It shows the given testing data set. Here's the working of the KNN. Yeah, and here's the accuracy we got for each iteration from 1 to 50. Here's the accuracy for each iteration. The graphical representation of the k value and the accuracy testing is being plotted, and here's it appears to be the in this format. Coming to the task 2, I have using the Kmeans. I've taken a simple dataset in the cars.csv, which takes all these things, required parameters. I have tested the data on Kmeans using we have asked to remove the null values here. So I have used the fill_na function here for removing the duplicates and null values, which eliminates the duplicate values and replaces by the mean or median function. And I have taken the k-means nearest neighbors to be size to be 11, for which I have found to be the best accuracy, which have been like trial and error method. The accuracy decreases after going further to the 11 function. And here is the working of the function. The classes are formed here, and we can see the each car data formed from different. I've taken the country data set to be the ones, and the cars per each country taken there. And here is the elbow method, where the number of clusters have graphed versus the WCSS. There, that's a column in the Kmeans cars.csv file. The remaining two functions are being implemented by Rutvik, and he's going to explain the remaining two applications. Thank you very much.